Hi Senior 1 students. In this lesson I'll explain three main points. Number 1, what are types of chemical formulas? Number 2, what is the relation between the empirical and molecular formulas? Number 3, how to find and calculate the empirical formula from the molecular formula and vice versa. Let's explain the first point. What are types of chemical formulas? There are three types of chemical formulas, which are empirical, molecular, and structural formulas. You will study the structural formula in details in Senior 3. The empirical formula is the chemical formula that represents the simplest ratio of atoms or ions of elements in a compound, as in the following example. CH2 is the empirical formula because it represents the simplest ratio of atoms in acetic acid C2H4O2 and glucose C6H12O6. Then acetic acid and glucose are examples of molecular formulas. We conclude that the molecular formula is the chemical formula that represents the real or actual number of atoms or ions in a compound. Not B. The empirical and molecular formulas are common in organic compounds, which consist mainly of carbon and hydrogen atoms. Let's move to the second point. What is the relation between molecular and empirical formulas? The following table explains many cases for empirical and molecular formulas. In example number 1, CH3H6 is the molecular formula of propylene, and to find its empirical formula, you must find the greatest common factor between 3 and 6. That is to say, number of units. It will be 3. Then its empirical formula will be CH2. You can apply the same idea in rest of examples. In examples number 3 and 4, the empirical and molecular formulas are the same because number of units equal 1. But in examples 5 and 6, molecular formulas of acetylene C2H2 and benzene C6H6 have the same empirical formula, which is CH, and its number of units 2 in acetylene and 6 in benzene. Let's understand how to calculate the empirical formula in the following example. First, you must check that sum of masses of elements such as oxygen and nitrogen forming a compound is 100%. When we add 25.9 to 74.1, the sum of its masses will be 100%. We will assume that 100 gram corresponds to 100%. Now we can calculate the empirical formula as follows. Step number 1, calculate number of moles of each element by dividing its mass by its atomic mass. Then in second step, find mole ratio by dividing number of moles of each element by the smallest value of number of moles. As you see, the smallest value of number of moles here is 1.85. After finding the mole ratio in this example, there is a problem. The mole ratio of oxygen is a decimal number, and it must be changed into integer number. So multiply both mole ratios of nitrogen and oxygen by 2 to get integer number. Then the empirical formula of this compound will be N2O5. By the way, its molecular formula is the same. Finally, how to calculate and find empirical formula from molecular formula and vice versa. In example number 1, ethylene glycol has empirical formula CH3O, and you can calculate its molar mass by doing algebraic sum of its atomic masses, 1 carbon plus 3 times atomic mass of hydrogen plus 1 times atomic mass of oxygen. The result will be 31 gram. Then to find number of units, divide molecular mass by mass of empirical formula, 62 over 31. Then the result will be 2 units. Then multiply number of units by empirical formula, C2 by empirical formula to find its molecular formula, and it will be C2H6O2. In example number 2, vitamin C has molecular formula C6H8O6, and to find its empirical formula you must find the greatest common factor between 6, 8 and 6, which is 2. Then its empirical formula will be C3H4O3, and you can calculate the values of empirical and molecular formula using their atomic masses. Now try to answer exercise number 2 and worksheet 7.